All right, we're going to go ahead and start going over this. So, when we talk about design, and we've said this the other day, I believe, the word design is often referred to as a generic term that's made up for anything made by the conscious human effort, meaning you intentionally made something up. When you make something, you invent something, you create something, you are automatically designing. Okay? It could be clothes, it could be shoes, it could be a computer. If you consciously tried to do it, you design. It's that simple. All right? You can also look off to the right where it says design is also a process that is used to systematically solve problems. Now, when we get into a word like systematically, all that's saying is that it becomes a process. So you're doing the same thing over and over and over and over again. And if you use this to solve even small problems, most of the time you're going to come up with the best solutions every single time. And that's exactly what you want. You want to solve problems. The one thing you don't want to do is just let them go. Right? I would. They're both. You can do all of it if you want to type. That's fine. If you want to sum it up, you can do that too. I would just say it's a design is when you come up with something or you invent something, and it is also a way to solve problems. If you are having troubles with the formatting, like you're typing too long or it's bleeding in, don't worry how it looks. Just make sure that you get it. Okay. So, again, just make sure you have something along the lines of whenever you intentionally make something or invent something or create something, not even necessarily something new, maybe it's something that you tweaked or you improved in some way, shape, or form. I saw a really cool quote this summer that said, anytime you see duct tape being used, you're looking at a design opportunity. Because why do we use duct tape? To fix stuff. Absolutely. Well, if you have to fix something, does that mean it was designed correctly? Or it was designed as well as it could have been? No. So anytime you see duct tape, you are looking at a design opportunity. Most people miss it because you can fix it with duct tape. Well, you shouldn't have to fix it with duct tape. Got it? All right. Moving on. So when we look at the design process, like we said, systematic problem-solving strategy used with criteria and constraints. These two words that start with a C, criteria and constraints, you will hear over and over and over and over and over again this semester. It's important that you start to understand what they're for. We'll get into them a little bit more in depth in a little bit. So with criteria and constraints, you use them to develop as many possible solutions to solve or satisfy human needs or wants, and to narrow down possible solutions to one choice. So this is a really fancy way of saying you see a problem, you come up with a bunch of solutions, you use a certain method to pick the best solution, and you try it. That's it. A lot of words to say a very simple thing. By the way, this is number 2 on your sheet. What is the design process? If you can paraphrase or simplify, you are more than welcome to do so. If you want to simplify it, you may simplify it. It's a systematic problem-solving strategy.
Wait, I don't want to sound simple, but don't you simplify in math?
Yeah, you can simplify in math too. You can use the design process to solve math problems if you wanted to. But most of the time, you already know the possible ways to solve it, so you don't need to come up with a bunch of solutions or a bunch of ideas. You could, but most of the time you know. If nothing else, make sure you have The design process is a systematic problem-solving strategy. At the very least, we need to type that down. This is actually a picture of the Saturn V rocket, which was used in the earliest NASA space exploration. It was one of the first things that made it into this outer space. I think the Saturn had something to do with the Apollo, but I'm not a NASA expert, so I don't really know. What's that? Right now we don't have a problem. But, Apollo? Apollo were the NASA missions that made it to the moon. So Apollo 11 was the first ever to make it to the moon. What? Apollo 13 was the movie with Tom Hanks. They had a problem. They were supposed to go to the moon. All right, moving on. In here, the design process is the exact same thing as what we use as the design cycle. Now, full disclosure, PLTW, their design process is different and has more steps than the design cycle. But for our purposes and for our MYP curriculum, we use this, the design process, our design cycle. So we use that colorful circle right here and the one on the wall, and we simplify it down to four steps. The other PLTW has like 6 or 7 steps. Okay? So we want to make it easier for you guys. Okay? Inquire and analyze the problem. Develop ideas. Create solutions. Evaluate the solutions. Okay, first one. Inquiring and analyzing. And on that sheet that you guys are working on, if I can find it, right in here, I'm going to give you the definition. You've got to supply the example. You don't necessarily have to do it right away. Get the definition. I'll give you some time to come back and think of an example. Okay? So, I'll probably give you examples too, so you could just write the ones I say if you really need to. So, write the definition here. Give an example there. Got it? Got it. All right. So, inquiring and analyzing a problem, super, super fancy way for saying identify a problem. Figure out what the problem is. This is the most important step, because if something's wrong and you can't figure out where the problem's coming from, we've got an issue. You can't solve it if you don't know what it is. So, identifying the problem. For example, if we were in this room and we started to smell smoke, is this the smelling of smoke, is that a problem? Yeah. Do we instantly freak out, get out of this room as fast as we can, and throw the switch? No. What we have to do next is we have to justify the problem. So we smell smoke. Instantly we know there's a problem. We've got to identify it. It's usually a good idea to kind of figure out where that smoke is coming from, right? Yeah. So let's say we get outside and we go in the hallway and we realize that 8th graders are burning cupcakes in Mrs. Clint's room. Now, we've identified what the problem is. We know where the smell is coming from. Big, big, big step. You have to justify the problem. Is it worth solving? So in that situation, we identified smoke's coming from Clint's room. Is that worth solving? Do we need to throw the fire alarm and get everybody out of the building? No. Okay? So you really have to ask yourselves, is the problem worth my time and energy? Cynthia said earlier she wanted to have more time. Your time and energy is finite, meaning it's limited. Some things aren't worth your time and energy. I will tell you, 90% of all the little drama that happens with students that I hear about, not worth your time. You choose to get involved because of pride or because you feel like you have to. But most of the time, not worth it. Okay? The sun will rise tomorrow despite what people said about your mama. Okay? That's just an example. Okay? The next step, and this was one that we don't necessarily go super far into, but you will next year if you go into the engineering stuff, is you want to research existing products. Meaning, has somebody already solved the problem already? You know, if I realize and I've come up with this great idea to fix something, but it's going to take me a lot of time, a lot of money, and a lot of energy to produce and create something, when all I could have done instead is done a Google search to see if somebody already fixed it. Okay? So it's a really good idea to save yourself that time, energy, and money and see if somebody's already fixed your problem for you somewhere or come up with a solution for it. We talked about math problems earlier. Most of the math problems you're going to see in your class, okay, all of them have already been solved. Somebody already figured out a way to solve them. So instead of you just trying to figure it out on your own, you can do a method that's already been proven to work, right? Doesn't that make sense? No, apparently not. Okay. Thanks, Caleb. All right. The next part is developing a design brief. And really what the design brief is it's just taking all these steps and compiling it in one spot, simplifying it in one spot. So then in one place you have your problem, why it's a problem, why it's worth solving, and if there's any other possible solutions already out there. Okay? That's a design brief. Now, here's what the design brief is. Before we go to the design brief too far, take a second and come up with an example of a problem. I'll give you a hint. Most of you already did this morning. I've already told you about a couple problems. Okay? So, have something typed into the example as well. All right. What? Now, hey, for definition, guys, really, just, you could put all that stuff, but I really just want you to make sure that you understand that you need to identify and justify a problem and figure out if somebody's already fixed it. That's really all you need for your definition. Okay, we only have a few minutes left, but I want to get just the design brief in here. Written plan that identifies what needs to be solved, and then we're going to come up with criterion constraints for it. What? I don't think there's you don't have to worry about a space for the design brief. I don't believe it's in there. Don't worry about it. But I just want you to know because you're going to be asked to do them eventually. We'll walk you through an example. But I tell you what, for now, that's all we're going to do for the day. If you want, you may shut down and plug back in.